In the first part of this course, we'll develop a Next.js app that is a fully static website. The app we'll build is a personal blog. Let me show you what it will look like once it's finished. As you can see, it's a simple blog website where we can post some articles that we'll write in Markdown files. And the app will automatically generate a page for each Markdown file. We'll also implement a dark mode switch, so our users can toggle between light and dark colors. So it's a fairly simple website to get us started with Next.js, but it will already teach us quite a few things. We'll see how to set up a Next.js project. We'll talk about pre-rendering. That is perhaps the biggest advantage of using Next.js rather than plain React. We'll cover page navigation and routing. We'll see how to style our components using a library called Styled JSX. A very important section explains how to load data in a Next.js page. In this example, we'll read the data from local Markdown files, but the concepts we learn here will be useful in many other cases, like if we want to fetch data from a web API. Then we'll see how to build a dynamic route that allows us to use the same component for generating multiple pages, in this case for all our blog posts. As we've seen, we'll add a dark mode switch, which will also be an example of how to write client-side functionality. And related to that, we'll learn about hydration, which is the mechanism used to add client-side functionality to components that were rendered on the server side. Finally, we'll see how to deploy our application, and we'll cover a few different options, from Vercel, that's the platform behind Next.js, to building our app in a way that can be deployed to any static hosting provider. So let's get started. In this video, we'll create our first Next.js project. Now, the easiest way to initialize a Next.js application is to use the Create Next App command line tool, and we'll look at this tool later in the course. But to begin with, I want to show you how to set up a new project entirely from scratch, because this will give you a better understanding of how a Next.js app is structured. Here I have Visual Studio Code open with its default welcome screen. What I'm going to do now is open a folder. I'll select my projects folder, which is where I like to keep my projects. And inside there, I'll create a new folder. Let's call it Next Blog, since it's a blog written using Next.js. So I'm going to open this new folder in Visual Studio Code. Right now, it's just empty, of course. Now let's go and create a new file called package.json. So we can use npm to manage the project dependencies like all modern JavaScript projects. Here we need at least a name that we can set to next blog, same as the folder name. And then let's set private to true, because this project is not a library that we want to publish to the npm registry. Okay, let's save this file. Now I'm going to open a new terminal inside Visual Studio Code. And here we can run the npm command line tool to install some dependencies. We want the next package, that is Next.js, and then React and React DOM, just like a regular React app. Let's wait a few seconds for npm to download all the dependencies. Okay, you can see that those three packages have been added to our package.json file under dependencies. And also there's a Node Modules folder with all the packages. Now inside here there's a .bin folder that contains command line tools installed along with the packages. And one of these tools is Next. This is the main tool we can use to manage our Next.js project. Let's see how it works. In the terminal we can use npx to execute that next command directly. And we can pass the --help option to see some usage instructions. It says that we can tell this tool to build, start, export, and so on. In fact, the first command we want to use is dev that starts our project in the development server. Let's try that out. Let's run npx next dev, and it failed with an error. What the error says is, couldn't find a pages directory, please create one. That's a helpful message. Not only says what the problem is, it also tells us how to fix it. So let's go and create a new folder at the top level of our project named Pages. Now, since we're going to use that next dev command all the time, I'll add a scripts section to our package.json file, and here configure a dev script that will execute next dev. This way, if we go back to our terminal, we can now type npm run dev, and this will take care of launching next dev as defined in our scripts. You can see that now that we have a pages folder, the development server started successfully, and it's running at this URL, localhost on port 3000. Let's open it in the web browser. What we get at the moment is a 404 not found page, which is not entirely surprising given that we haven't created any pages yet. But this already shows that the development server is working. I'll resize these windows so I can show you the editor and the browser side by side. And let me hide the terminal. The dev server will still be running in the background, of course. It is now time to create our first Next.js page. Inside our Pages folder, we want to add a new file, which we want to call index.js, because it will be the index page of our application. But what exactly is a page in a Next.js project? For now, you can think of a page simply as a standard React component. Let's write a function component called homepage, since that's what the index page is, and here we'll return some JSX elements, like all React function components. I like having a main element as the root of a page to use semantic HTML. And here we could have a simple h1 heading saying my blog, for example. So this is just a very simple React component. The only other thing we need to do is to export the component as the default export of this file. With this, we can now save this file and try and reload the same URL in the browser. You can see that it works. Our homepage component is being displayed as the index page of our application. I'll open the Chrome Developer Tools so we can see any console messages. And since we're running our Next.js app in development mode, this means that if we make any changes to our code, like if I write Mirko's blog here, as soon as I save, the app updates automatically, reflecting the latest changes, as you would expect when working with a modern web framework. Let me quickly revert this change. Now, before we move on, note how the next command created a .next folder in our project. You don't really need to worry about what's inside here, but if you use get in your project, make sure to add that folder to your .gitignore file, because it contains temporary build files that shouldn't be kept in version control. Just like you want to ignore the node modules folder with all the dependencies. So this was just a quick note if you use get. But with that aside, we created our first Next.js project and wrote our first page, which, as it turns out, is simply a normal React component. But as simple as this page may look right now, believe it or not, there's already a big difference between how this page is rendered with Next.js and how a similar page would be rendered in a plain React app. We'll see exactly what's different in the next video. Now that we have a Next.js project set up with a simple index page, we can see what is perhaps the main feature provided by Next.js compared to a normal React project. And that feature is pre-rendering. To show you exactly what that means, I have created a standard React project using the Create React App tool. So in my projects folder, along with the next blog project we created in the last video, I now have a React blog as well. And if I open that React blog folder in Visual Studio Code, This is the initial project as generated by Create React App. What I'm going to do now is remove everything from this app component. Then I'm going back to our Next.js project and copy exactly the same JSX elements. So our plain React page will look exactly the same as our Next.js page, and we can compare the two. Now I'm going to open a terminal and run npm start to launch the React dev server. It's not starting straight away because it detected that something is already running on port 3000, and that something is our Next.js app. But that's okay, we just need to type yes and it will start on a different port. In fact, it's running on port 3001, and here's our React app displayed in the browser. Now I'm going to open the Chrome Developer Tools and look at the network requests. Let me select only doc or documents, that is HTML files. Then I'm going to reload the app, and we can see a request for localhost and port 3001. Now, if we look at the response, we can see the HTML returned by the server. If we scroll to the body, here you can see that this page basically contains only a single empty div. So how can we see the My Blog heading displayed in the page if it's not in this HTML? As you probably know already, that's because after loading this initial HTML file from the server, the browser also loads these JavaScript files. And when that JavaScript code is executed, our React component is inserted into the page. In other words, React components are normally rendered on the client side, which means in the browser. We can further prove this if we go to the settings, and down here there should be an option to disable JavaScript. Now, with JavaScript disabled, if we try reloading the page, it doesn't work anymore. It just says you need to enable JavaScript, which is the text that was inside the noScript tag in the HTML. Without JavaScript, our React component cannot be rendered by the browser. Now let me go and re-enable JavaScript. Otherwise, not many things will work. So that's what happens with a plain React app. Now let's go back to our Next.js app that's still running on port 3000. What happens in this case if we look at the network requests? Let's try and reload this page. We can see a localhost request, but the HTML for this page is all in one line, so it's a bit difficult to see. What I'm going to do is copy the whole HTML and go and paste it into the editor so we can look at it more easily. Let me set the file type to HTML and also format this document so it's no longer all in a single line. If we look inside the body, you can see that there's a div element, and inside that we can see our main tag with the h1 heading. So the React component we wrote in our index.js file has been pre-rendered. The HTML file returned by the server already contains the component elements. Now, you may notice that this file also includes a bunch of JavaScript files as well. And that's because in a Next.js app, we may still want some functionality that runs on the client side. For example, if we want to do something when the user clicks on a button. But for this simple page, the HTML actually already contains all the content. Let's do the same experiment as before and see what happens if we disable JavaScript. Let's reload the page. And as you can see, our page still works fine. It renders correctly even with JavaScript disabled. This proves that the rendering happened on the server side. Let me re-enable JavaScript so we can keep developing our app. But this is the main difference between a normal React app and a Next.js app. Whenever possible, Next.js pre-renders our React components. This has a few advantages. For a start, our app will feel faster because the page content becomes visible as soon as the HTML is loaded, without waiting for any JavaScript code to be loaded and executed. But also this helps with SEO, or search engine optimization, because pages that have all their content in HTML are easier for search engines to crawl compared to pages that require JavaScript. In other words, thanks to pre-rendering, your pages may rank higher in Google and other search results. We've seen how Next.js pre-renders our React components so that the HTML page returned by the server already includes the elements defined in our home page component. But how does this work exactly? Let me close this HTML file now so we can go back to our JavaScript code. How does Next.js render this component to HTML on the server? Well, let's show our terminal where the server is running and see what's going on there. Let's add a log statement inside our component function so we can see when this component is rendered. Now, if I save this file, you can see the render message being logged in the browser console. That's because the component was updated using fast refresh, which is a bit special in that it only happens in development mode. But let's see what happens if we go and reload the page when the browser requests the page from the server. You can see that the render message shows up in the server logs. This means that our component is rendered on the server. The server takes our JavaScript code and generates the HTML page returned to the browser. Interestingly, the same message is also displayed in the browser console. So our React component is rendered twice, once by the server and once in the browser. Now, you may be wondering why it needs to be rendered again in the browser if it was already rendered by the server. And we'll talk more about this later in the course, but for now, let's say it's in case we need client-side functionality, like responding to the user clicking a button. Anyway, if you pay close attention, you'll notice that the render on the server happens before the one on the client. Let me reload the page again so you can hopefully see it. What happens is that when we load the page in the browser requests the page from the server. So that's when the server renders our component to HTML to return the HTML page to the browser. After that, the browser displays the page, but it also loads the JavaScript files included by the HTML. And at that point, it will execute the JavaScript code that renders the component in the browser. The other thing to notice is that every time we reload the page, the component is re-rendered by the server. This happens because we are currently running the Next.js server in dev mode. So it re-renders our page every time to make sure it reflects the latest changes we made to the code. But this is not actually what happens when we run our Next.js application in production. Let me stop the dev server so I can show you how to run it in production mode. As we've seen before, the Next tool supports a few different commands. So far, we always run next dev, but there are other options like build and start. In fact, build and then start is exactly what we need to do to run the app in production mode. Let's try this out. We can add some scripts to our package.json file. So in addition to dev, we want a build task that executes next build, and then a start command that runs next start. Once we have these scripts, we can run them with npm. Let's do an npm run build, which will generate a production build of our Next.js app. Now, let me show you the full output. There are a few interesting things here. First of all, notice that as part of the build, Next.js generates static pages. It doesn't just compile and bundle our JavaScript code like a normal React project. It also generates static HTML pages. And it's during that step that it rendered our home page component, as we can tell because it printed our log message here. The other interesting thing is that at the end it shows a summary of all the files it has generated, including JavaScript files, their size, and so on. but for now let's focus on the pages. It has generated a page for the root path, which corresponds to our index.js file containing our home page component. And it also generated a 404 page automatically, which is always needed if somebody requests a page that doesn't exist. Now, notice how before each page there's a symbol, and for both these pages it's an empty circle. It explains what that means at the bottom. An empty circle means that's a static page, which means a page that's automatically rendered as static HTML. There are other possible types of pages: server, SSG, that stands for static site generation, or ISR, which means incremental static regeneration. We'll cover these other page types in the following sections, but for now it's good to know that our index page is a fully static page. Now let's see what happens when we run the app in production mode. We can do that by typing simply npm start, and this starts the server on the same port as the dev server, that is port 3000. But in this case it's running in production mode. If we load the home page, it looks the same as before, obviously. And it logged our render message in the browser console, which happens after the HTML is loaded when the JavaScript code is executed. But if you notice, there is no render message printed in the server logs. Remember how in dev mode the server re-rendered our component every time we reloaded the page, but not in production mode. That's because in this case the HTML page has already been generated during the build step. So all the server needs to do is return that static HTML file. We can see that file if we look inside the .next folder, under server and then pages. Here's the index.html file that was generated by the build command. If I format this document so it's a bit easier to read, here inside the body you can see our home page component as rendered to HTML. So the Next.js server can simply return this HTML file every time the browser requests the page. It doesn't need to regenerate it every time. Now let me stop the production server and restart the dev server so we can keep developing. Just keep in mind that there are some differences between the dev and production server. In dev mode, as we've seen, the page is re-rendered by the server every time we request it. And by the way, we'll also talk more about how to run our Next.js app in production later in the course. The key point of this video was showing how Next.js generates static HTML pages at build time. We've seen how our home page is rendered into a static HTML file by Next.js, but we still have a single page in our application. What if we want to add another page to our blog website? For example, we may want an About page visible at the /about path. If we try this now, of course, we'll get a 404 not found. Now, a typical React app is a single page application, but you can use something like React Router to display a different component based on the URL path. This requires defining a route that specifies that path and the component to render, in this case the About component. So there's some amount of, let's call it, configuration involved. In a Next.js app, creating a new route is actually a lot simpler. All we need to do is add a new file under the Pages folder, just like we already have the index.js file. So we can just create a new file and call it about.js. So the name is the same as the path where we want it to be visible at. As we know, a page in Next.js is simply a React component. In fact, we could even copy everything from our home page and then rename home page to about page. Incidentally, you can call your component whatever you like. As long as it's the default export, it makes no difference to Next.js. So you could call it simply about instead of about page, but I find it more descriptive to call them something page. Now let's change the heading to say about as well. Save this file and go and reload it in the browser. And just like that, our new page is visible under the /about path. Really simple. No configuration required. This works because Next.js uses a file system-based router. What this means is that the Next.js server looks inside the pages folder and automatically exposes each file in there under a URL path. So our about.js file is automatically mapped to the /about path. It's basically the name of the file without the extension. As for the index.js file, that's a bit of a special case, because that's not visible at /index, but simply at the root path. We need a way to show a page at the root of our website, so Next.js uses index.js for that purpose, which should be pretty intuitive. But apart from this special case, any JavaScript file you put inside that pages folder will be visible as a web page under the same path as the file name. You can try creating another page yourself with the name of your choosing and verify that you can open it in the browser. We added a new About page to our website, but if we go to the home page, there's actually no way for the user to navigate to that About page. So let's go and add a link into our home page. In fact, we probably want a navigation bar inside a header, where we could add other links as well. Now, in a React component, we need a single root element in JSX. So I'm wrapping everything inside a fragment, which is this special empty tag. Inside the header, we can have a nav element, which in turn contains a list. And then we can have a list item for every link in our navigation bar. Let's start by using a regular a tag linking to /about, and the text can say about. So we have a very basic navigation bar. We'll add some styles later to make it look nicer, but we can click the About link and it takes us to the About page. Of course, we can also go back using the browser back button. That's all pretty straightforward, but let's look in more detail at the network requests. And I'm only interested in documents, that is HTML files. Now, if we reload this page, we can see a request for localhost, which really means the index page. When we click the About link, notice how it loaded the About page. So it replaced the whole document. The browser unloaded the home page and loaded the About page as a completely separate document. And if we go back, you can see the same thing happening in reverse. It discarded the About page and loaded the home page from the server again. That's how traditional websites work, where each page is a separate HTML file. But it's different from a typical React app that is a single-page application, and all the navigation is done on the client side. Client-side navigation is actually faster, because it doesn't load a completely separate HTML file from the server every time we navigate to a new page. So does this mean that by using Next.js we're losing one of the advantages of React apps? Of course not. We can use client-side navigation even in Next.js apps. All we need to do is use a component provided by Next.js called link. That's from the Next Link module. And the way it works is that we simply wrap our anchor element in this link component, and then we need to pass the href property to the link itself rather than the a tag. You can actually wrap any elements you want in a link, so you could also have an image, for example, inside here. Now let's save this file and see what difference this makes. Let's reload the home again. And of course, the browser requested the HTML file for the home page. Now let's go and click the About link. And this time, notice how the browser didn't make any other request. There's still only localhost, so it didn't request the About page. That's because the Next router is now doing client-side navigation. It already preloaded everything necessary to display the About component when we loaded the home page. So it didn't have to make any additional requests, which means that the navigation was a lot faster as well. That also works if we use the back button. It simply replaces the React component on the page instead of reloading the whole document from the server. So by using Next.js, we can basically have the best of both worlds. We get very quick client-side navigation, just like a single-page React app, but we can also go directly to the /about URL and get a pre-rendered HTML page from the server like a traditional multi-page web application. All we need to do to take advantage of these features is remember to wrap all our links in the next link component. We added a navigation link to our blog app, so we can go from the home page to the About page. But once we get here, there are no links to navigate elsewhere. We probably want the navigation bar to be displayed on the About page as well. We could simply copy this nav block into the other page, but to make it more reusable, let's put it into its own component. So let's create a new file. Let's call it navbar.js. This will be a regular React component. And in its body, we can return the same elements we copied from our home page. We also need to make sure to import the link component, and I'll use the auto-import feature provided by Visual Studio Code. So it automatically added the correct import line at the top. And finally, we want to export this navbar as the default. Okay, we can save this file. And now, in our home page, we can import that navbar component from the file we just created. At this point, we can use it to replace this block of code with our new component. Let's save these changes and go back to the home page. It's still showing the About link at the top that we can click to go to the other page. So the navbar component is working. But we're still not showing any links in this About page. Let's go and add the navbar to the About page as well. We can wrap everything in a fragment first, so we can have multiple elements inside. And here we can add a header with our navbar component that I'll auto-import. And that should be it. We can see the navbar at the top. However, the only link is to the About page itself, so that's not particularly useful. We want to add another link to our navbar. Let's copy this list item and duplicate it. Then we can change the href to / and the text to home. And we now have a link to the home page as well. So we can click home and navigate back and forth between our two pages. So that's all working fine. But there's actually a small problem with this navbar at the moment. I have created this component in the same folder as our pages. Can you think why this may be a problem? We've seen a couple of videos ago that Next.js uses a file system-based router, where all the files under the Pages folder are automatically exposed as web pages. This means that right now we could open the navbar URL, and we can see our navbar component displayed as a full page. That's obviously not what we want, because the navbar is not meant to be a standalone page. It's just a reusable component that we want to include in our pages. So how do we stop this navbar component from being exposed as a web page? As you might guess, we need to move it somewhere else outside of the Pages folder. A common approach is to create a components folder at the top of our project. So we can now move navbar.js inside that separate components folder. Let's confirm. Visual Studio Code can automatically update the imports in our code, so let's accept. And we should see that in index.js, the navbar is now being imported from inside our components folder. But we still need to save this file ourselves, because the editor updated the import but didn't actually save the change. That's why the page in the browser is showing an error. If we save the About page as well, that should fix it. And it's now importing the navbar from inside the components folder. We can quickly check that everything still works. Good. So that's it for this video. We've seen how we can create reusable components in our app, just like in any other React app. The only thing we need to be careful about with Next.js is that we should not put our components inside the Pages folder, unless we want them to be visible directly as web pages. In the previous step, we introduced this navbar component that we are then using in both our pages. By writing a shared component, we can avoid duplicating the same code over multiple pages. However, there is still some duplication between our pages. They all share the same basic structure with a header and a main section. In fact, it's not unusual for all the pages in a website to share the same general layout. It would be nice to be able to define such layout in a single place, like in a sort of template. With Next.js, we can do that by creating a custom app component. Inside Pages, we can create a new file named _app.js. The name begins with an underscore because it's a special file. It's not a regular page, but it's still a React component, so we can write a function component as usual. Now, this component will receive some props that are passed automatically by the Next.js framework. One such prop is called component. This is the page component corresponding to the page being displayed. So if we render in the index page, for example, component will be the home page. But if we load the /about path, it will be our about page component. The other prop we need is called page props. And as the name suggests, this contains props that we need to pass to the page component. As a minimum, in our app, we want to render the component representing the current page, and we need to pass all the page props to that component using the object spread syntax. Then, as usual, we need to export this as the default export for this module. So, like this, our custom app component simply renders the desired page without adding anything. Now, let's add at least a logging statement here, so we can see when this component is rendered. Okay, let's save this file. Now, when we first create a custom app component, we need to manually restart the dev server. This is one of the very few cases where the dev server does not automatically pick up the changes. And that's because the app component is special in that it's used for all the pages. So let's stop the server with Ctrl+C and then launch npm run dev again. Let's hide this terminal and reload the app. You can see in the browser console that our new app component was rendered first, and then the home page was also rendered. So this proves that our app component is getting called. Now, what we wanted to do is extract the common page layout from our existing pages. So let's copy all these elements and go and paste them into the app component. But here we want to keep only the common elements. The main section will be different for each page. So let's remove this. And in its place, we want to render this page-specific component. So each page can basically insert its own elements into this sort of template. If we save now, well, there's an error, because I forgot to import the navbar component. But if we fix that, the app component will render the common navbar. In fact, we see two navbars on the page now. That's because the home page also displays its own header. So we can remove it from here now, given that it's already provided by the common app component. And this way we should see a single navbar. We can actually remove this import as well. Okay, the home page is working. If we go to the About page, again we'll see the navbar twice, because the About page still adds its own header. Let's remove it from here as well, and also get rid of the import. And that's it. The About page looks good. By the way, we could remove the fragment that wraps the main element in this code, but it will be useful later on when we add some more stuff, so I'm going to leave it there. Also, note in the browser console how the app component is always rendered before every page. In fact, now that we've seen this, I'm going to remove that log statement. Otherwise, it will keep being logged every single time. Okay, but this is how a custom app component works in Next.js. It's the perfect place to write code that applies to all the pages in your application. We introduced a custom app component where we keep the common elements, so that in each page we only keep the parts that are specific to that page. Now, there's something else that we typically want to add to each page, and that's a title. You can see that at the moment the browser tab simply displays the URL, and it's the same if we look at the About page as well. That's because in our pages at the moment we don't define a title. And I mean the title element that you can put inside the head tag in HTML. It's simply not present in here. How can we add a title to each page? It's slightly tricky because our components are usually rendered inside the body of the document. But in this case, we need to add something to the head of the HTML. Thankfully, Next.js provides a head component that we can use exactly for this purpose. We can put this head component wherever we want inside our JSX elements, and anything we write inside here will be added to the document head. So we can use this to set a title, for example, my blog. And once we save this, you can see that the title in the browser tab changed to my blog. Also, if we go and look inside the document head, there is now a title element, exactly as we wrote it in our component. This can be used to set any elements that go inside the head. So in addition to the title, we could set a meta tag with a description, which is something that can be useful for search engines. Let's just write "this is my blog" as an example. And that meta tag is, of course, added to the document head. It's been added dynamically here because we're running in dev mode, but remember that Next.js will build static HTML pages for production. So this tag will be present in the static HTML, which will be used by search engines. Anyway, for this simple blog, we don't really need to worry about SEO. Let's just keep the title. Okay, now let's go and add the same to the About page as well. Let me show that page in the browser. So we can paste our head section, and we can simply change the title to say About. We also need to import this head component, and that should be that. You can see our new title displayed in the browser tab, just as we expected. Note that the title will also change dynamically when we navigate from one page to the other. Even though, as we've seen, this kind of navigation happens client-side without reloading the HTML page from the server. The Next.js head component will dynamically update the values inside the document head. And that's all for this video. The head component is very simple to use, but also very useful for setting the page title and other meta tags. In this video, we'll start adding some styles to our application. So far, everything in our page is displayed using the default browser styles. which doesn't make for a great look. The most basic way to add some styles is to add a regular CSS file that is used for the entire website. Let's start with this approach. Let's create a styles folder at the top of our project, just to keep the CSS files separate from the rest of our code. And inside that folder, let's create a new file called globals.css, since it will contain global styles. Here we can add some CSS rules. For example, we may want to set a font family. And I'll accept this suggestion, which is a common choice of sans serif fonts. Okay, let's save this file. Now, for these styles to actually be used, we need to import that CSS file into our custom app component. Relative to the pages folder, it's up one level and then styles globals.css. And if we save, you can now see that the page is using a different font. You can actually import any CSS file you like into your app component, and it will be applied globally. It doesn't have to be called globals.css, that's just an arbitrary name. In fact, you could also import multiple CSS files if you want to. Anyway, let's go and add some more styles to make our app look a bit nicer. Maybe we could change the color of the links and set it to dark red, for example. I'm using a named color for simplicity, but of course you could select a custom shade using the color picker. Anyway, if we save this change, the links become dark red. We could also remove the underline by setting text decoration to none, and that's the result. There's no need to underline those links because they're in the navigation bar. However, we could show the underline when the link is focused or when the user moves the mouse over it. So in this case, set the text decoration back to underline. And if we save this, it should underline the links when we hover over them, which can help the user a little bit. Now, those links are still displayed as a bulleted list, which is not really what we want in a navigation bar. Let's remind ourselves of the structure of that nav bar. As you can see here, there's a UL element that is an unordered list that contains an LI or list item element for each link. So we want to restyle the UL element to remove the bullet points. And that can be done by setting list style type to none. Okay, the bullet points are gone, but there's still a lot of space before each link. Let's remove it by setting padding to 0. That's better. Now, we also want to display those links all in the same line. So let's go and install the LI elements and set them to display inline. So they're all on the same row, but there's no space between them now. Let's add a bit of a margin, maybe on the left, so before each link. And let's set it to 0.75 rem units. That's more readable. Ideally, we don't really need the margin before the first item. So we could set the margin only on items that are not the first child. So let's set the margin left only in this case, and if we save, the home link is aligned to the left. Okay, that's enough for this example. As you probably know, you can easily spend a lot of time fiddling with the styles to make your app look really nice. But since this course is not specifically about CSS, I'll keep the styles fairly basic. The important thing to know is that with Next.js, you can have global CSS files that apply to your entire app simply by importing them into your _app.js file. In the next video, we'll see how to define component level styles as opposed to global styles. In the previous video, we added a CSS file to our app containing global styles that apply to all our pages. Now, keeping all the styles in a global CSS file doesn't work so well when our app becomes larger and we add many different pages and components. For example, here we added some rules for the UL and LI elements used in the navigation bar. But as they are, these rules really apply to any UL and LI elements anywhere in our application. What happens if we have a list of items somewhere else, like in our home page? Let's add a list here, for example, with some test items saying 1, 2, and 3. You can see that in the page, these items are displayed all in a single line, because it's applying the same rules we defined in our global CSS file written for the navigation bar. But if we have a list in the main section of the page, we probably want that list to be displayed as bullet points. So we need a way to apply these rules only to the UL elements that are inside the navigation bar. In this simple example, we could apply them only inside a nav element. And that would work fine in this case. You can see that the links at the top are all on the same line, while the list in the main content is displayed with bullet points. This works in this case because we have a single nav element in our page. But what if we have another nav element somewhere else, and we want to style it differently? To be absolutely sure those styles only apply to the elements inside our NavBar component, we could add a class name to the root element, named like the React component itself. So now that nav element has class NavBar, and we can use this in our CSS selectors. Instead of applying these styles to all nav elements, we can apply them only to those who have class NavBar. And the result is the same, but our rules are more specific. So this is a better approach. But having to add a CSS class to each React component by hand, and then writing the correct rules in a global CSS file, is still a bit of a pain, especially once our code grows and we have lots of components. That's why these days there are many libraries available for React that give us component-scoped styles. In this example, we're going to use Styled JSX, which is a library created by Vercel, that is the same company behind Next.js. But this is just one of many possible options. Next.js also supports CSS modules out of the box. And if you prefer some other library that works with React, it should work with Next.js as well. But let's have a look at how Styled JSX works. Let's comment out these global navbar styles for now, and let's re-implement them using Styled JSX. We can actually remove this class name as well. Okay, with Styled JSX, we can write our CSS rules directly inside our JSX elements. All we need to do is add the style element with a special property called JSX. We can insert this style element wherever we like inside the JSX tree for our component, but typically we put it just before the end, like this. Now, inside the element, we want a JSX expression that is a backtick delimited string. This way, the string can span multiple lines, and inside here we can write our styles using the regular CSS syntax. For example, let's style our UL element. Let's go and copy the same styles we were using in our global CSS file and just paste them here. If we save, you can see that the styles have been applied to the navbar. If we look at the elements as rendered in the browser, you can see how Styled JSX automatically added a class to the nav element, a class with a unique ID that starts with JSX and then some random number. And the same class is applied to all the elements inside the navbar as well. That's how Styled JSX makes sure that our styles only apply to this component. It's basically similar to what we did earlier when we manually added a class to our navbar component, except that now Styled JSX is doing it automatically for us. Okay, now that we've seen how it works, let's go and copy the other styles as well, and paste all the rules inside our component styles. We can remove the navbar class, since these styles are already isolated. Okay, if we save now, the links in the navbar have the expected styles, but the other list in the main content is not affected. Alright, we can now go and remove those styles from the global CSS file. All the navbar specific styles are now inside the component itself, where they belong. I should also mention that to get syntax highlighting and code completion, I had to install a couple of Visual Studio Code extensions. One is called Styled JSX Syntax Highlighting, and the other one is the Styled JSX Language Server. So you may want to install those extensions as well. But this is how Styled JSX works. Personally, I like having all the styles in the same place as the component code. That's what makes Styled JSX a so-called CSS in JS solution. And I also like being able to use the regular CSS syntax. But if you prefer some other styling solution for React, as I mentioned, you should be able to use it with Next.js as well. Now that we added some styling to our blog website, I want to cover another small thing that has to do with the appearance, and that's the fav icon. Perhaps you noticed before that when we load the page, sometimes we get a not found error for favicon.ico. And you can also notice that the icon shown in the browser tab is just a generic one, because we don't currently have a custom icon for our website. So for a start, let's go and find an image that we can use as the icon. And I'll choose one from this favicon.io, which is one of the many favicon generators you can find out there. For simplicity, I'll just select one of the emoji icons. And I know there's one called infinity, that is this infinity symbol. Feel free to pick a different icon if you see one you like better. So I'll download this image, and this is actually a zip file that we can open. It contains a few different variants of the same image in different sizes and formats that can be useful if you want to support devices like Android and iOS. But for this example, we're going to use a single image. Now, the question is, where should we put that icon inside our project? With Next.js, we can have a folder called public, and any file we put inside that folder will be served as it is to the browser. Let's start with a different example. We can create a robots.txt file that, as you probably know, can be used to tell search engines which pages they can index. In our blog website, we want to let all search engines access all the pages, so these will be the rules. Now that we have that file inside the public folder, we can request robots.txt in the browser, and we get exactly the same content we just wrote in the editor. So the file is simply returned as it is, unlike the JavaScript files that we have inside the pages folder that are processed and rendered to HTML before they are returned to the browser. Okay, now that we have that public folder, we can copy our favicon file inside public, and this should now be used as the icon for our website. You can see that the icon is visible in the browser tab. Okay, so this works because the browser requests that favicon.ico URL by default. But we can also explicitly declare where to load our icon from. And we want to do that in our app component, since it applies to all the pages. Now, the tag for the icon goes inside the document head. So if you remember, we can use the next head component for that. And we want a link element with rel icon, which is the relationship type, and then the href property will point to the image file. In this case, it's /favicon.ico, because the file is directly inside the public folder, so it's visible under the root of our website. And if we save, our icon still works. But we're not limited to keeping all the files directly under public, of course. we can have subfolders. For example, create one for icons. And if we move our image inside there, then it will be accessible in the browser at a different path. That's why we now get a 404 not found, because the file is no longer at that URL. It's now under the /icons path, so if we change the href, then the icon will work again. Let me reload just to show that the error disappears. But you could already tell by looking at the icon in the Browser tab. Just to be clear, I only moved the icon to a different path to show you how the public folder works. We could have left the icon in the default location, of course. But the point is that you can use this public folder to keep any assets you want to use in your web pages. They can be images, fonts, videos, anything that should be served as it is. You can put it inside here and reference it from your pages. We've seen how we can use the public folder to keep images and other assets used in our pages. Now, we're building a blog website, but we still have no blog posts. So it's time to write our first blog post. And we could start by adding a link to what will be the page for our blog post. We may want all the posts under the same path, and under there we will have different pages, starting with a first post, for example. Here we need an anchor element with the title for this link that can be again first post. Now let me remove these other list items, and in our page we see the link to first post. Of course, if we click that link, we'll get a 404 page because we haven't actually created the page for that URL yet. You should know by now how to create a page. So why don't you pause this video and try and add that page yourself? There's just a tiny challenge here in that the page must be in a subpath. I'll wait just a couple of seconds before showing you the solution. Okay, let's see how to create that first post page. We know that pages go inside the Pages folder, but in this case we first want to create a subfolder called Posts. And inside that subfolder we'll create a firstpost.js file. So that's how we'll get this page exposed as /posts/firstpost in the URL. Now we need our component code, and I'll copy that from our About page just to save some time. Let's rename About page to First Post page, and also change the title accordingly. And this is a good starting point for our new page. If we try opening that link again, we can see our new First Post page. That's pretty simple. Now we could add a paragraph with the content of our post, like "This is my first ever blog post." And we could keep writing more content into this page, but writing an article by hand using JSX elements inside a React component is probably not the best approach. Maybe we could use Markdown instead. We'll look at that in the next video. So we created this first post page, but we also mentioned that it will be better to write our blog posts in Markdown format. So let's open a new editor tab and set the file type to Markdown. In Markdown, we can write a header by starting the line with a hash mark, so we could use this for the title. And then we can write a paragraph simply as normal text without special tags. Let's also note that this post was written using Markdown. Now, in Visual Studio Code, we can also preview it. If we open the command palette by pressing Command-Shift-P or Control-Shift-P if you're not on macOS, here you can search all available commands, and there is one called Markdown Open Preview to the side. So if I press Enter, we can see the rendered Markdown on the right, and we can keep adding content on the left, like some bold text, for example. Or we could add a list starting each line with an asterisk that will be displayed as a bullet point. So this is a much better way to write an article compared to writing it directly inside a React component. Now let's save this Markdown file, and I'll create a new folder called Content just to keep it separate from the rest of our code. Inside Content, we could have another folder called Posts, and this is where we want to save this file. I'll have to find that folder in this dialog now. Okay, and we can call this file firstpost.md. There you go. So our challenge now is, how do we take this Markdown file and display it as the content of our first post page? This will require quite a few separate steps. We need to read that file, parse the Markdown, and render it to HTML, but also see how we can load data in a Next.js page. We'll cover all of this in the next few videos. To recap, we created this first post page, but we'd like to load the content to be displayed inside that page from this Markdown file. To get there step by step, let's leave the Markdown aside for the moment, and instead look at how we can load some data into a Next.js page. It doesn't really matter if that data comes from a local Markdown file or somewhere else, like an external API. We know that a Next.js page is a React component, and you should also know that we can pass props to a React component. Let's log those props when the component is rendered. At the moment, props is just an empty object. In other words, there are no props passed to this component, which is perhaps not surprising because this component is a page, so in a sense, it's the top-level component of our application. There's nothing passing props down to this component. But in Next.js, there is actually a way for us to pass some props to a page, which is useful precisely to load some data that can then be displayed in the page. To do that, we need to create a function named getStaticProps, and this function needs to be exported and also async. Because loading data is usually done asynchronously, so it makes sense to return a promise. Now, this function returns an object, or more accurately, a promise of an object, since it's async, and this object contains the props that we want to pass to our page component. As props, we can pass whatever we want, so let's start with a couple of test values. And if we save this now, we need to reload the page because those props are set server-side. But you can see in the browser console that the first post page component received the value we returned in our getStaticProps function. Okay, now that we know how to pass props, we can use this to pass the post data. Each post can have a title like first post, and then let's call it the body, will contain the main content for this post. Let's specify that this comes from static props, so it will be clearer once we load it into the page. And if we reload the page, of course, we should see our post object received in the props. Okay, at this point, we can use that post data in our component. We can extract the post prop, since it's the only one we expect, and then replace anywhere we wrote first post with the post title. While inside this paragraph, we want to display the post body. So with this, you can see that the page is now displaying my first post as static props. It updated using fast refresh, but it will be the same if we reload the page, of course. Okay, so this is how we can pass props to a page component in Next.js. So far, we hard-coded these props inside our getStaticProps function, but later on we'll load the post data from our Markdown file. Before we get to that, though, in the next video I want to show you in more detail how getStaticProps works in terms of when Next.js calls that function, and also why it's called getStaticProps. We wrote our first getStaticProps function to pass props to our page component. Now let's make sure we fully understand how it works. Let's start by checking when this function is called by adding a logging statement. And I'll print the page name as well as the function. Now let's open the terminal so we can look at the server logs. I'll clear everything so it's easier to see the new messages. When we load the page, you can see that the getStaticProps function is called on the server side, but not in the browser, while our component render function, as we know, is called both by the server and in the client. So that's the first interesting thing. getStaticProps is only executed on the server to generate the HTML returned to the browser. If we reload the page, then getStaticProps is called again, so it's called before every render. And this is because we are currently running the app in the dev server. We'll see in a minute what happens in production mode. But first I want to point out this peculiarity of writing Next.js apps. In this same file, we have our component function that's executed both by the server and in the browser. And this is already different from a normal React app where everything runs in the browser. But now we also have this getStaticProps function that only runs in the server. So in the same file, we have a mix of server-side and client-side code. This is different from most other frameworks, where you either write server-side code or you write client-side code. This can be a bit confusing at first, but it is actually one of the advantages of using Next.js. This component page and the function that populates its props are strictly related, so it makes sense to keep them in the same file. The fact that they can then be executed in two different environments is more of a deployment concern. And Next.js takes care of that for us by intelligently deciding which code needs to run where. It's pretty clever if you think about it. Now let's see what happens when we build our app for production. Let's run npm run build and look at the output. The getStaticProps function is called while generating static pages. And in fact, it's logged just before rendering our first post page component, which makes sense because you need the props to render the component. Now, if we look at the build summary, remember how our other pages, that is home and about, are marked with an empty circle, which means they are static, as in automatically rendered as static HTML, and they use no initial props. If we look at our new first post page, this one has a filled circle instead. And a filled circle means it's SSG, or static site generation, which is explained as automatically generated as static HTML plus JSON, and uses getStaticProps. So Next.js treats pages with a getStaticProps function slightly differently from fully static pages. For most practical purposes, static or SSG are pretty much the same. We can deploy both types of pages to any web server as static files. But let's see why it says that it generates HTML plus JSON rather than just HTML. Here's the first post.html file generated by the build process. And if we look inside it, we can see our React component pre-rendered to HTML as usual, and it used the prop values we returned in our getStaticProps function, which are the post title and body. So far, nothing strange. But in addition to the HTML file, the build also generated this JSON file. As you can see, this file simply contains our page props in JSON format. So again, why does Next.js generate that separate JSON file with our props? To explain that, let's run the app in production mode with npm start. Now, if we reload the page, you'll see that nothing gets logged in the server. Let me clear the logs to make it more obvious. Nothing gets logged, so our getStaticProps function is not called, because the page is already available as a static HTML file generated during the build. We can check that by looking at the network requests. And the server response will be the same firstPost.html file we opened in the editor a minute ago. This is what happens when we load the first post page directly. But what if we start from the home page instead? We know that in this case, the browser loads the HTML file for the home page, but when we click the first post link, Next.js uses client-side navigation to open the new page. So in this case, the browser does not load the full HTML page for the first post. Instead, if we look at all the requests, not just HTML, the browser loaded that firstPost.json file that we've seen in the build folder. So the browser will render the first post page component by loading the props from this JSON file. And this solves that small mystery of why Next.js generates a JSON file along with the HTML for an SSG page. It's used to support client-side navigation. Now let's restart our dev server so we can continue our development. But hopefully this video has given you a better understanding of how getStaticProps works. And you can probably see why the function is called getStaticProps, because those props are set at build time and used to render static HTML pages. Now that we know how getStaticProps works, let's go back to our original plan that was to load the post data from this Markdown file. To take one step at a time, in this video we'll focus only on how to read a file and leave parsing the Markdown for later. So for now, let's assume we want to load the data from a JSON file called firstPost.json. This will contain a JSON object with our post details, that is, the title, and the body, that for now can be some simple text. But let's write that this is in a JSON file, so we'll see something different when we load the data. Okay, starting with the JSON file simplifies our task a little bit, in that now we just need to figure out how to read a file from this code. Now, if this code was meant to run inside the browser, it wouldn't really be possible to read a local file that's inside our project. But remember that the getStaticProps function runs on the server, which really means in Node.js. So in our function, we can use any of the APIs provided by Node.js. And Node.js provides a module called FileSystem, or FS for short, which includes a function called readFile that does exactly what the name says. So let's see how to use this function in our code. First, we want to import that function from the FS module, and I'll use the promises variant that's more convenient. So that module should contain a function named readFile. Now we can call readFile here, and we want to pass it the path to the file, which is under the content and then posts folders inside our project. So the path is content/posts/firstpost.json, and this is relative to the project folder because that's where the server runs. We also need to pass a second argument with the character encoding, in this case UTF-8. Now, this function returns the data inside that file, but it's asynchronous, so we need to await the result. Let's quickly log the data so we can see exactly what that function returns. Let me show the server logs. And if we reload this page, you can see that the data is in fact the content of the JSON file as we expected. Okay, so at this point we can get the post details simply by parsing that JSON data. And that post object is what we want to return in our props instead of these hard-coded values. Let's see if this works. I'll show the server logs as well. And if we reload the page now, we can see that it displays my first post in a JSON file. So it's clearly reading the data from the file. Of course, the server logs printed the same data. Let's stop here for this video. This is how we can read data from a local file, but perhaps more importantly, we've also seen that in our getStaticProps function we can use any of the functionality provided by Node.js, because this code only runs on the server. We've seen how to load some data from a local file in our getStaticProps function. Now I'd like to do some refactoring and extract that bit of logic into its own separate module to follow the separation of concerns design principle. Let's start by creating a separate function inside this file. Let's call it getPost. And this function will read the post data, so we can just copy our existing code. Except that here we can return the post object directly. So now we can call this getPost function inside getStaticProps and get the post object by awaiting the promise returned by getPost. We're doing a refactoring, so the functionality of our app should stay the same, but it's always good to check. Now, at the moment, we're always loading the first post, but we can make our getPost function more general by passing which post to load as an argument, and then accept it as a parameter here that I'll call slug, meaning the part of the URL that identifies a specific post. Now we can change this string to be backtick delimited so that we can insert the slug as a placeholder. And let's quickly check that we didn't break anything. It's all good. What I'd like to do now is move that function to a separate module, because this file is really about rendering a page. So the details of how to get the data don't really belong in here. A common approach in Next.js apps is to have a lib folder at the top level of the project that contains any code that's not specific to pages or other visual components. So here we could create a module called posts, since it will contain functions to get the post data. And we can simply move the function we just wrote from the first post page. We just need to make sure to export it from this module, so we can then go and import it in the other file. And I'll use the auto-import feature so the editor automatically finds the right path. Let's save, and we have an error now. That's why it's good to test the app after every change, so if anything breaks, it's easier to fix. In this case, I simply forgot to move the read file import into the new posts module where it's actually used. If I save both files now, that error should go away. Okay, it's working again, and that's all the refactoring I wanted to do. Note how this way, in this file to get the post data, we simply call the getPost function. There's nothing in here about how to get that data. And that's a good thing, because in this page we're only interested in getting the data so we can display it. The fact that the post data comes from a local file is irrelevant as far as displaying the page is concerned. That's why it's good practice to encapsulate that sort of logic in a separate layer of our application that deals with fetching the data. Okay, we've extracted the logic to read the post file in its own module, but we're still reading the data from a JSON file rather than from the Markdown file, which was our ultimate goal. To be able to use the contents of this file, we need a way to parse the Markdown format and transform it to HTML that we'll then insert into our page. There are quite a few libraries available in JavaScript to work with Markdown. In this example, we'll use one called Marked that's very easy to use. Let's see how it works. For a start, we'll need to install that library, so let me open the package.json where we have our dependencies. Let's open the terminal and stop the dev server, because we need to run npm install and download the marked package. Okay, now I want to show you quickly how that library works, and I'll do that by starting an interactive node prompt. Let's start by importing the marked module, and I'm using require instead of import just because import statements are still not supported when running Node.js in this way. But once we have the marked function, we can use it to generate some HTML from a markdown string. Let's write a markdown header, for example. And if we print that HTML, you can see that it generated an h1 heading in HTML. So it's very simple to use. Now let's restart our Next.js dev server. And let's go and use that library to read Markdown files. So in this file, we want to import the marked function from the module with the same name. Now, reading the data from the file will work in the same way, except that we want to read a Markdown file instead of a JSON one. At this point, we want to transform that data, that is a Markdown string, to HTML using marked. And I think I'm going to rename this variable because data is a bit too vague. Let's call it source instead, as in the Markdown source. Now, we no longer need to parse any JSON, but we still need to return an object from here, because that's what we expect where we use the post data. If you remember, in the page we expect the post to have a title and a body. So the getPost function should return an object with those two properties. But here we have a small problem in that we parse the Markdown into a single HTML variable. So we could return the HTML as the body of the post, but right now we don't really have a separate title to return. That's okay for now. We'll see how to add metadata to our Markdown file in the next video. For the time being, the title will just be empty, which is not ideal, but shouldn't break anything. So let's save these changes and see what's being displayed in the page now. You can see that it's clearly reading the content from our Markdown file and converting it to HTML. The problem is that it's actually displaying the HTML source code rather than rendering it. And that's because in our page component, we're currently displaying the post body as the child of a paragraph element. So React will escape any special HTML characters contained in the post body string. But in this case, we actually want to insert the post body directly as HTML. So how can we do that? Let's remove this paragraph, since our post body could potentially contain multiple paragraphs. Let's use an article element instead to contain the post body, which is semantically more appropriate. Now, React provides a way to insert HTML directly inside an element by using a prop called dangerously set inner HTML. And it's called like that because setting the HTML directly can be dangerous from a security point of view. If the HTML we're setting here comes from content entered by our users, they could use this to inject scripts into our page. But in this case, we know that the content always comes from Markdown files that we wrote, so it's not a problem here. Now, to set this prop, we need to pass a JavaScript object that's inside a JSX expression, so you end up with double curly braces. This object must have a property called __HTML, and this is where we pass our post body variable. React makes this deliberately convoluted because they want developers to think very carefully before setting the inner HTML directly. Anyway, if we save this now, you can see that the page displays the content as we expected. So it rendered the markdown we had in our post file in a suitable way. The markdown header is shown as a h1 heading in the page. The text within double underscores is displayed as bold text, and so on. Okay, so now that we are finally using the content from the markdown file, we can delete this JSON file that we wrote just as a stepping stone. And to recap, we added the marked library to parse the markdown into HTML, and we're using dangerously set inner HTML to display that HTML directly into the page. In our post page, we're now displaying the content from our markdown file as the body of the post. But we're missing a separate title property, as we can notice in the browser tab title. That's because when we parse the markdown, we get the result as a single HTML string. So how could we extract the title from our markdown file? The best approach is to add a front matter to this file. The front matter is a block at the beginning of a file delimited by triple minus signs, and it contains metadata in YAML format. So we can use this block to define arbitrary properties related to this file, for example, the title. This way, we'll be able to extract these properties separately from the rest of the file. Now, if we define the title separately, we don't need to repeat it in the main content as well. So let's remove this header. The question at this point is, how do we extract those properties from the front matter where we read that file? We'll need to change this logic a little bit to first parse the front matter and then render the markdown. And to parse the front matter, we'll use another library called grayMatter. Let's look at an example. Given a string that starts with a front matter block and then some other content, grayMatter will return an object containing both the main content and a data object with the properties defined in the front matter. Let's keep this in mind as we go and use that library in our project. First of all, we'll need to install that package as usual. So I'm going to stop the dev server and run npm install grayMatter. Let's restart the dev server again and go back to our JavaScript code. In this file, we want to import that library. Let's call it simply matter, even though the module is grayMatter. And this is a function that we can call to parse the content of the file, that is our source. As we've seen in the documentation, this returns an object with data and content properties, where data contains the properties defined in the front matter, and content is the rest of the file, that in our case is in Markdown format. So this is what we want to convert to HTML. But now we can also return a title property, because that will be available in the data extracted from the front matter. Okay, let's save this file and see if it works. I'll reload the page just in case, but you can see in the browser tab that it's displaying the title correctly. And if you look at the message in the browser console, you can see the title there as well. Okay, so that's how we can attach properties to a post. We only set a title so far, but we can add any properties we like here. For example, it would be useful to have a date showing when the post was written. And this could be a date string in ISO format like this. So if we save this file now, we can go and use that date. In our getPost function, we simply want to return the date extracted from the front matter data. And then in the page, we can add maybe a simple paragraph with the post date. I'm not going to worry about the styling for this example, but you can see the date displayed at the top of the page. Okay, so that's how the front matter works. We could actually simplify this code a little bit by destructuring the data properties directly here. So then in the post object, we can use shorthand property names for date and title. And at this point, we could even rename HTML to body. And finally, we could move all the properties to the same line to make the code shorter. That was just a bit of refactoring that shouldn't change the functionality. But with this, we are finally done with rendering our first post page, loading the Markdown and everything. So in the next video, we'll see how to add more posts. At this stage, our app can display our first post, loading the content from a Markdown file. Now, what if we want to add another blog post? We could create another Markdown file, let's say second post, and let's change the date, the title to say second, and same in the body. We can remove the rest for this example. Now, how do we display the data in the new Markdown file? We could create another page here, but it will be very similar to this existing first post page. Almost all the code in this page would stay exactly the same when displaying a different post. The only thing that needs to change is the value we pass to getPost that specifies which file to load. So it would be nice to be able to reuse the code in this page for all the posts. We can easily rename this component to simply post page rather than first post page. And our app still works fine because the name of our component doesn't really matter as long as it's the default export. But as it is, this page will still be visible only under the first post path. Because, as we know, the Next.js router exposes each page based on its file name. What if we want the same component to be used for multiple pages under /posts, like a sort of wildcard match? Next.js allows us to define dynamic routes by naming this page in a special way. We can write square brackets, and inside that the name of the path parameter, for example, slug. This is a strange name for a file, but it's perfectly legal to have square brackets in a file name. So the idea is that any URL that starts with posts/something will match our posts/slug page. But we need to do something else before this works. We now get an error that says getStaticPaths is required for dynamic SSG pages. So we need to add a getStaticPaths function to our code. This is similar to getStaticProps in that it must be exported and async, but the purpose of this function is to tell Next.js which paths are valid for this dynamic route. Let's implement this function and you'll see what I mean. This function returns an object that contains a paths array. And each item in this array is an object that in turn contains a params object with parameters that identify this specific route. For example, in our case, we want to set a parameter called slug because that's what we put inside square brackets in the file name. Now, we know that our existing page was visible under posts/first post, so we can set slug to first post here. We are basically telling Next.js that first post is one of the valid paths for our post page. But now we can add more paths, for example, add a second post here. So this way, Next.js knows that posts/second post is also a valid URL. Now, the object returned by getStaticPaths must also include a fallback property that in our case we want to set to false. The fallback option tells Next.js what to do if none of the paths above matches the requested URL. Setting it to false means no match will result in a 404 not found page, which is what we want in this case. Next.js also provides some more advanced features where if a page doesn't exist, you can try building it on demand. But in that case, your website will no longer be fully static. Now, the path we set in getStaticPaths will be available in getStaticProps. This function receives an argument called context. Let's start by logging that context so we'll see exactly what it contains. Now let me show the browser window again, and also the server logs. Let's reload the page and see what gets logged. Here's the call to getStaticProps, and the context object contains some params with the slug set to first post. Let's go through what happened step by step to make sure we understand what's going on. In the browser, we requested the post's first post URL. The Next.js server received the request and matched it to our slug in square brackets page because it's under the posts folder and it's a dynamic route, so it matches anything. But for this particular request, the slug parameter is set to first post. Then Next.js executes our getStaticPaths function to check if first post is in fact a valid path for this page. And it finds that it matches the first item in our paths array, so first post is a valid request, and Next.js goes on to call the getStaticProps function, passing the matching path in the context. In getStaticProps, we then load the post data from the Markdown file, which is then passed as props to the component render function that renders the HTML as usual. Now, what happens if we request second post instead? The page still says first post, but that's just because at the moment we always load the same Markdown file. If we look at the server logs, however, we can see that this time getStaticProps was called with second post as the slug parameter. So we should make use of that slug parameter in our getStaticProps function to load the data for the right post. Let's destructure this context object and extract the params. In fact, we could even go one level deeper and get the slug directly from here. And now, instead of always loading the first post data, we can pass the slug here. This should work because we named our Markdown files in the same way as our URL paths. So if we save this change, we can immediately see that the page now shows the second post data, so it's loading the right Markdown file. Let's make sure everything else still works. If we start from the first post, that still shows the right content. And if we request the second post, we need to enter the path manually because we haven't added a link to it yet. But of course, that also works fine. So that's how dynamic routes work in Next.js. There are a few moving parts here. We need to name the page file with this special square bracket syntax to match any request under the post's path. Write a getStaticPaths function that says which paths are actually valid, and then use the params passed in the context to getStaticProps to load the right data. We made our post page a dynamic route, so the same page component will be used for all the posts. And the paths we return in the getStaticPaths function will inform Next.js of which posts actually exist. But why do we need to write each post slug manually in here? We could just look at the content posts folder, see which Markdown files it contains, and generate the list of static paths automatically. This way, if we add more Markdown files, they will automatically be visible as post pages. This is exactly what we'll do in this video. Just like we have a getPost function that reads a Markdown file, we can add another function that will list all the files and return their slugs. Now, how do we get a list of files? In addition to readFile, the Node.js file system module provides a readDir function. And we can use this function to read all the files inside our content posts folder. readDir returns an array of files, and it's asynchronous. At this point, we have the list of files, so our files array will contain the file names as strings, firstpost.md and secondpost.md. But in our getSlugs function, we want to return just the slugs that are effectively the file names but without extension. So we want to take the files array and transform it. First, I'd like to filter it and keep only the files that end in .md, just in case there are any other files inside that folder that are not Markdown, we should just ignore them. And then we want to map or transform each file to remove its extension. For that, we can use the slice method. And we want to keep all characters from the beginning of the string up until 3 characters from the end, so -3. Let me show you quickly why -3. If we have a string with a file name, like somepost.md, then slice from 0 to -3 will return somepost. .md is 3 characters, so to stop before that we write -3. In fact, we could actually make this more explicit in our code by defining a constant called suffix, which is our file extension, and then instead of .md we can use that suffix, and instead of this magic number we can write suffix.length. That's the same thing, but it should be more readable. Anyway, this function should now return all the slugs for our posts based on the Markdown file names. Now we can go and use our new function inside getStaticPaths. We'll get all available slugs by awaiting the result of calling getSlugs. Now we want to use the slugs to generate the paths. I'll write it above the old paths for now. Slugs is an array of strings, so we want to transform each element into an object, because each element in the paths array must contain a params property, and inside params we can simply pass our slug value. So our new paths array contains the same type of elements as our old one, and we can delete the old one now. Let's save and check if this works. The second post page is still working. Now, if we start from home and open the first post, this also works. So the existing paths are still valid. But now we can try adding another post. I'll simply duplicate the second post and call it third post, and then change the content as well to say third everywhere. And just by adding that new Markdown file, we should now be able to request the third post path, and this shows a page with the content loaded from the new file. This worked without us having to write third post manually in the getStaticPaths function, because now it automatically finds all the available Markdown files by reading the directory contents. We're now generating the list of available posts automatically based on the Markdown files present inside our content folder. But there's another place where we still have a manual list of posts, and that's the home page. In fact, right now we're only showing a link to the first post here. We could change the home page code to call our new getSlugs function and automatically generate a list of links for all the available posts. Now, we know that there's a way to pass some props to a page component. So here's a mini challenge for you. Why don't you pause this video and try to implement this step yourself? We want the home page to receive the list of post slugs returned by the getSlugs function and just log them for now. Do you remember how to do that? I'll wait just a couple of seconds before moving on to the solution. Okay, so the way we can pass some props to a page component is by writing a getStaticProps function. Here we can call getSlugs that we can auto-import, and this will return the slugs, but as a promise that we need to await. The getStaticProps function always returns an object with the props, and in this case we want our props to contain the slugs. Okay, let's save this file and see what happens. We'll need to reload the page for getStaticProps to get called, but you can see that the home page component received an array of slugs with the 3 available posts. Okay, at this point we could use those slugs to generate the list of links in the page by repeating the list item element using a different slug on each link. There's a small problem though. In addition to the slug, in the link we also show the post title, and we don't currently have this in our props. So just calling getSlugs is not enough. We'll need to write another function that gives us not only the slugs, but also the titles of all posts. Let's create that new function, as usual exported and async, and let's call it getPosts. Here we can start by getting all the slugs by calling our existing getSlugs function, and then we can build an array of posts. That is what we want to return from this function. And to fill that array, we want to iterate through each slug. Given a slug, we can get a full post object by calling our other existing function, that is getPost. And at this point, we can simply add this post to the array. Okay, let's see if this works. In our home page, we want to use getPosts instead of getSlugs, and we'll get a list of posts. That's what we'll pass in the props. If we reload the page, we can see that the home page received an array with 3 posts, and each post object has body, date, and title. So that's not quite what we wanted, because we also need the slug for each post to generate a link, and that's missing from these properties. So let's go and modify our getPosts function a little bit, and when we push each element, we can create an object that includes the slug, and then expand all the other post properties using the spread syntax. Let's save these changes and try again. If we look at an individual post now, you can see that we have the slug in addition to the other properties. We only really need slug and title, so we could actually remove the body, but that's an optimization that I'm not going to worry about for this example. Rather, let's go and make use of those posts we receive in the home page props now. We want to repeat each list item element, so let's take the posts and map each post to the JSX elements displaying a link to that post. We can reuse our existing list item element, but we want to replace the href with an expression. And I'm using a template literal so we can insert the post slug inside this string. Finally, we can display the post title as the link text. And let's not forget to add a key to each item. As you probably know, in React, whenever we have an array of elements, we need to set a key on each element that uniquely identifies it. So here we could use the post slug that should be unique. And with this, we can save. And we see 3 links in the page, 1 for every available post. Let's refresh the page just in case, and test those links. The second post works fine, and so does the third one. So looks like our task for this video is done. And this is how we can generate a list of links automatically in our home page. We are simply using a getStaticProps function to populate the list of available posts.